Hello, everyone. This is Group 5 with Anshu Sharma and Ibrahim Aliami. And today we are going to talk about a project that we have done this semester. The title of our project is a comparative study of techniques for Cura question duplication detection and topic modeling. Okay. And this is the outline of our presentation for today. We will have introduction, application, and we will have two main points that we are going to talk about. The first part is semantic similarity implementation, and the second one is the topic modeling implementation that my classmate will talk about. For both of the implementation, we will have methodology, results, and analysis. And at the end, we will have conclusion and references. So Cura is a QA website that received a lot of questions, and a lot of these questions actually are duplicated. So in our work, we wanted to detect whether if a user asks questions, we want to see if that question is already asked for or not. And the second goal of this project is to automatically extract topics from these questions. The reason we chose this project is because help these kind of websites, the QA websites, to reduce the duplicated questions and label the new questions with topic tags. That will increase the overall experience for people who use these kind of websites. Another application of this website is to make it easier for chatbots to respond, because these kind of bots receive a lot of questions from people. A lot of these questions might be duplicated, so it making it easy for chatbots to detect the similarity of these questions. But when I say similarity of question, I mean semantic similarity. It's an area of NLP. So basically, if we have two texts and we wanted to see the similarity of those text, the text might have similar words, not similar, different words that have the same meaning. So we would like to detect the semantic similarity of these two texts, for example. So we have applied 3 layers in our model. The first layer called locality sensitive hashing, LSH. And then the second layer is cosine similarity. And then the last one is Needleman-Wunsch algorithm. Before we apply these layers, we had to clean our data a little bit. So we applied NLP techniques such as normalization to normalize the text. And then we tokenized the text into word-by-word tokenization. And then actually we removed the punctuations like question mark or any special signs in the text. And then we send the clean data to our first layer, the LSH. So what's LSH? LSH actually, it's a approximate search algorithm that give us an approximate candidates. So we chose this algorithm because since our data sets has thousands of questions, we don't need to deal with this amount of questions, because that's gonna cost a lot of time and space. So this algorithm actually is used in big companies like Google and Facebook to just like give an approximate results for what we're looking for. And it consists of 3 main tasks. The first task in LSH is shingling. Shingling basically is about unigram or bigram the text into tokens. And then the next stage of LSH is min-hash algorithm. So basically hashing the shingling into pieces, so it making the data a little bit less than the actual data. And then the final stage of LSH is just like bring us the candidates that look similar to each other. So we say we say that we need 100 candidates out of this layer, which is like 100 questions, to go to the next layer. Next layer is cosine similarity. So cosine similarity basically calculate the similarity between two vectors. Now, since we are receiving the candidates as a set of text, we needed a BERT, which basically BERT is a Google tool that used to, for example, to transfer the text into vectors. And then we calculate every single vector with the query that a user enter for any question that a user enter. And then we save the cosine similarity score for each candidate. And then we pick only the best similar questions. For example, the most questions that have maybe 85% of cosine similarity or above. The rest we don't care, because if a question receives 0.1 out of 1, that means this question is not really similar of what we're looking for. So we remove these kind of questions. So the last layer actually is the Needleman-Wunsch algorithm, and this algorithm is a dynamic algorithm. Basically, it calculates the similarity of biology sequences. It is used in biology, like to calculate the similarity of DNA. But in our case, we adopted a library called MiniNeedle, and we changed that library to suit our project. For example, instead of just like comparing character by character, we make it comparing word by word, and that's going to save the time and space of our model. And we added like some features, for example, synonyms, because there are some words that look different, the form of the word, but they have the same meaning. So we apply synonyms, lemmatization, and part of speech to the Needleman-Wunsch to get more accurate results of our model. So how did we test our model? Actually, we used something called spot checking. Spot checking actually is just like picking a random question from the data sets and apply our model on it. You can find the set of questions on this link if you click on it. So the question that we picked actually is divided into two groups, 10 duplicated questions, and the other 10 is not duplicated. So when we try our model on the duplicated questions, we got 9 out of 10 questions that our model could predict as duplicated, and only one question our model couldn't predict. For the non-duplicated questions, on the other hand, the result wasn't really that good. We only were able to detect 5 out of 10 as non-duplicated questions, and the other failed to predict. So the overall performance of our model was 70% successfully prediction. And then finally, we compare our results against this paper, for example. They have like 83.5 accuracy on their model, and they have more questions, like 200 questions. We only have 20 in our case. So that's why actually in our model it was good, but it's clearly we have some limitations. For example, we could pick more than 20 questions, like 200 questions, to compare our results. Maybe we can try different layers like Jaccard similarity or Euclidean or Manhattan distance. We could also try other criteria to test our model, like F1 precision or recall, to improve the overall accuracy of our model. Right now, Anshu will talk about topic modeling.
Okay, so another task that we did was about topic modeling. So what is topic modeling? So topic modeling basically is the process of recognizing and extracting topics present in a corpus of data. So what we did was we used Quora questions data set to figure out if we can extract topics from each of the questions. So we use three major topic modeling techniques. They are techniques or algorithms. They are latent Dirichlet algorithm, LDA, non-negative matrix factorization, NMF, and latent semantic analysis, LSA. So these topic modeling techniques all run on the assumption that documents have a set number of topics and each topic is a collection of words. So that is the basic assumption of these kind of techniques. So basically, LSA is a statistical model, while LDA is a probabilistic model, while NMF is also a statistical model, but it's mostly works on a non-negative term by document matrix. So what we did was we took the Quora insincere question data set, because we didn't just have one data set that just had questions for us, and the insincere question data set had one extra column which we didn't need, so we just threw the column out and we cleaned the data. We checked if there are like unnecessary empty data sets, empty rows. We removed those. We removed parentheses and special characters, and we also removed alphanumerical values and stop words, and we lemmatized our questions. But we didn't do too much in-depth pre-processing, because as we know, as now we'll know that Quora questions only are allowed 250 characters. And if we start doing like rigorous pre-processing methods in the questions, we might start losing out information from it, because 250 characters is not long. So we kept pre-processing to pretty much minimum. And next, we generated models for each of our implementations of the algorithms, NMF, LSA, and then our LDA algorithm. And after that, we tested 50 questions with every one of our algorithms, and we generate 15 topics per question. So for 50 questions, for each questions, we had 15 topics. And then after the test cases were generated, we evaluated our questions. So for our actual label against which we compared, we extracted the topics from Quora. That the actual topic labels that was given in Quora was taken as the goal data set. The goal labels. So we compared the topics that were generated by our algorithm with the goal data set that we extracted from Quora. So what we did was we evaluated with n equals to 1 topic, and we also did it with n equals to 2 topic, n equals to 5, n equals to 10, and n equals to 15 topics with the labels that we extracted from Quora. And the evaluation metrics that we used were Rouge, Blue, and exact matched metric. So exact, Rouge and Blue are one of the standard metrics that are used to check the generated words with some reference words. While exact match metric, what we did was we basically just compared whatever we got from Quora whatever we got from our algorithms was exact match with the values that our implementation generated. So next is this is an example of what our LSA model generated. So our text was, how can I spend 16 hours in Hong Kong International Airport? And our LSA algorithm generated time, happen, feel, day, long, book, job, travel, person, spend, study, world, period, movie, and possible as probability as our probable topics. As you can see, the probable topics are not that good. And moving on to our results, when we looked at moving on to results, we can see that our results are actually pretty bad. The best F1 score we got was 0.027. So next, we see why that happened. So turns out, after we did all of this, we found out that next, please. We found out that results are pretty bad, but it is consistent with previous research that topic extraction is pretty bad on short form text. That is because all of these, our algorithms apparently do not work that well with words with a corpus of words that are less than 50 words long. And Quora just has 250 character length. So we found out that there is an existing gap in the research area, that algorithms do not perform well on short form text. And why is that? It's because short form text lack word co-occurrence, because just 250 characters of text, or like with tweets and with questions, there is not much word co-occurrence, and there isn't much context happening in those data. So because of that, the algorithms cannot perform well. And also there's issue during data pre-processing, like I mentioned before, that if we start doing rigorous data pre-processing, then we start losing even more context that is already lost. And also there's lack of gold standard data sets. Like I said, we just pulled labels from Quora, but Quora's algorithm is kind of just haphazard, whatever they employ. So there's a lack of gold standard data sets as well, which also kind of hampered the results of our experiment. So finally, what we learned is that, first of all, we did a 3-layer model on Quora duplicate question detection using LSH, cosine similarity, and Needleman-Wunsch. And we achieved 70% accuracy on 20 questions, which is pretty good. But on our topic modeling portion of our project, we found out that topic modeling actually does poorly with short form data. And we found out that there is a plenty of gap in research that can be fulfilled moving forward with further research. Thank you.